Hi, this is Tom, and welcome to Lesson 28. This one's called Multiplication Rule and Permutations. Alright, let's get going. In the last video, we were drawing tree diagrams for multiple choice questions. And I made the comment that if we were to extend this idea out to 3-question tests, that we'd have to draw a tree with 27 branches. And the idea is, how did I know that without having to draw it? Well, that's what we're going to explore today. So we're going to begin, like we have in the past, with another tree diagram, and we're going to see what we can learn from that. So here's what we're going to do. Suppose we have 3 books. We have 3 books, and they could have creative names, but for the sake of simplicity, we'll call them Book A, Book B, and Book C. And the question is how many ways? How many ways can these be organized on a shelf? Organized on a shelf. Well, let's find out. So what we do is this. Let's see here. Notice that we're going to have, I'm going to draw, this is a funny looking bookshelf, but we have our first slot. Maybe we'll have a second slot. And our third slot. Oops, I spelled that wrong. Third slot. And final, we're going to put the arrangement here. The arrangement of the books. All right, well, here we go. So, yeah, you don't really have to be too careful, but maybe we'll start out here. We have a book. Book. And what we want to do is organize our books on the shelf. So when I first go to organize my books, I can place book A in the first spot, or I could place B in the first spot, or I could place C in the first spot. So when I come to the first slot, I have those 3 different options for which book would go there. Now, let's just suppose that we began with A. We put A in. Now, when we go to the second slot, we only have 2 books left to choose from. We could either put B or we could put C. Now let's just say we'll continue this tree out and then we'll go back down. So let's say I first put A in, then I put B in. Well, then in my third position, there's only one thing to choose, and that would be C. But suppose I first started with A, then I used book C. Well, now the third slot would have to be B. And now let's come back. So suppose that we first put book B in. Well, now in the second slot, we can either put A or we could put C. And then if we put A in, well, only C can go in the last position. If we went B, then C, then the last one has to be A. Or suppose we put C as the first slot. Well, we can either put in A or we can put in B. If we used A in the next spot, B goes in the third slot. If we put B in the second slot, then A goes in the third slot. And that's the tree. Now we're going to do a few things with this. I'm going to bring a line under this for a moment. And let's write our arrangement, and I'll do the first one kind of slow. Notice that the idea was here. We had A, then a B, and then a C. So my first arrangement was A, B, C. And then let's take a look at a second one here. Second one might have been A, C, and B. And so A, C, and B. I would encourage you to pause the video here and try to write the rest of these arrangements and see if yours match mine, and then we'll go from there. But I'll continue on right now quickly. Hopefully you pause the video and try this yourself. So my next arrangement will be B, A, C. My next arrangement will be B, C, A. My next one will be C, A, B. My final arrangement is C, B, A. So notice that how many arrangements? If I count these up, I have 1, 2, 3, 4, 5, 6. I have 6 different arrangements. Now, the question is we know this is 6, but is there a way we could have known that without making a tree? That's the difficulty. How to do this without first making the tree. Well, notice that on the first slot that we could have put 3 books. We could have either put in A, B, or C. When we came to the second slot, though, we only had 2 books that could go in there. And when we came to the third slot, there was only one different option that was left. Now, this is kind of a funny question because I was going to say, how, using 3, 2, and 1, how can you get to 6? And this one works both by adding or by multiplying. But what we really want is we want multiply. Notice if we multiply 3 times 2 times 1, we come up with 6 different ways to organize the books on the shelf. And so now let's make this a little more interesting, a little bit more challenging. So now suppose we have 7 books on a shelf. Suppose we have 7 books. And again, the question is, how many ways to organize? How many ways to organize 7 books on a shelf? Well, if we use the idea, question mark, if we use what we just learned from above, let's think of it, instead of making the tree, let's think of it this way. We have our first slot, our second slot, and our third slot. So in this problem here, we're going to have a first slot, a second slot, a third slot, a fourth slot, a fifth slot, a sixth slot, and finally a 7th slot. So when we come to the first slot, notice that we would put in, there's 7 books to choose from. And then when we come to the second slot, well, we used one already, so there's 6 that could go in the second slot. Well, now we've used another one, so there's only 5 available for this third slot. And if we keep this process going, we get 4 times 3 times 2 times 1. And just like we did above, we're going to multiply those together. And if you do that, you're going to come up with a rather large number of 5,040. Now, there's 2 different things that we need to recognize here. The first, the idea that all of this result here, the 5,040, is found by multiplication. And that brings us to the multiplication rule, and it says this. Well, let's write this out. Multiplication rule. And it says that if there are n different objects, each with k possibilities. Let's write that. K possibilities. Possibilities. Then there is K1 times K2 times K3 times dot 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 Kn ways something can happen. Can happen. So in this way, in this one, there's 7 different slots on the book, on the shelf, and so the K1 was, for example, would be the first slot on the shelf, of which 7 things could happen, and K2 would be the second slot on the shelf, for which 6 things could happen. Now, in the problem that we just looked at, our n was 7. That's the total number of places that we have to figure out. So for that bookshelf, there were 7 different things. Now, the other thing we wanted to look at is this. This is up here, is the idea of this descending multiplication. Well, notice that what happens is it goes down by the next whole number. So it goes 7, 6, 5, 4, 3, 2, 1, and then it stops. Well, actually, this pattern is used quite regularly in counting, and we call it this. We say it's the same as 7 followed by an exclamation mark. And we read that as 7 factorial. And so it always starts that way, where it begins with the first number and then it stops at 1. Stops at 1. And you can do this on your calculator as well. For example, you should check it if you were to type the number 7. And then on your calculator, you'll see the button that says, oops, correct that. It says math. And then if you'll scroll across the top, you'll see on some of the older ones that you'll see either PRB, or on the newer ones, I think it's PROB. But go over to that, press enter. And then if you scroll down, you'll see an exclamation mark down below. So scroll down to that and press enter. And now it'll take you back to your screen, and on your screen you're going to see 7 exclamation mark, and then just type enter again. And it should give you 5,040 different ways to organize your books on the shelf. Hope that helps. And in the next video, we're going to find out, well, what if you still have 7 books, but now you have a smaller bookshelf? See you in the next video. Thanks for watching.